Chapter 18, question 143. Okay, we have three compounds here. Now, each compound has two different functional groups, ketone and aldehyde. Okay, ketone, aldehyde, ketone, aldehyde. Now, ketone is at different positions in the ring for all these three compounds. Okay, now, these three compounds, each of them is treated separately with excess sodium borohydride, right? This is reduction, okay? And then treated with excess concentrated sulfuric acid. Now, this is dehydration. Elimination. So we are going to reduce the ketone and aldehyde to secondary and primary alcohols first, then after that dehydrate the compound. Okay, now what do they want us to find? They want us to find which compounds give only one final product with the molecular formula C7H10. So now we are going to look at the compound one by one. So I'm going to start with compound number 1. Okay, compound number 1, yep. Now if I do reduction of this compound number 1, okay, the ketone will be reduced to a secondary alcohol, and the aldehyde will be reduced to a primary alcohol. After that, we have to do dehydration of these alcohols. Right, now I'm going to show all the hydrogen bonded to the carbon so that it is easier for us to do dehydration later. Okay, all these carbons are bonded to 2 hydrogen, yeah? Make it a bit small. No enough space. Okay. Alright. Now, to do dehydration, I have to remove the OH group and then 1 hydrogen from the neighbor carbon. So this hydroxyl group, okay, can be dehydrated by removing H from this carbon or this carbon. Right? Now here we can only remove the hydrogen from this neighbor, this adjacent carbon. So we are going to get 2 different products. Let's draw the 2 different products first. So first I want to remove this hydrogen. Let me use different color. Just circle this. Okay, if I remove this hydrogen and this OH group, then this OH group and also this hydrogen. Now what would I get is a compound that look like this. Okay, double bond between this carbon and this carbon. After that, okay, remove this. Oh, sorry, I shouldn't have drawn that line. Okay, an alkene here. So let's check the molecular formula. 1, 2, 3, 4, 5, 6, 7 carbon, C7. Hydrogen, 1, 2, 3, 4, 5, 6. 5 here, 6, 7, Okay, 8, 9. Oh, 10. One more. Okay, C7H10. So yes, this is C7H10. Now, I said that we remove one hydrogen from this carbon, right? So now let's remove the hydrogen from this carbon instead. This one. Okay, this one instead, yeah? Don't remove this. Okay, then I'll get another product. This one's still the same. We can only remove hydrogen from this carbon because there's the only adjacent carbon that has hydrogen. Okay, then I'll get this. So this is still C7H10. Okay, 7 carbon, 6 here in the ring, and 7. 10 hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 bonded to this carbon. So both also C7H10, but they are different C7H10 because the double bond is in the is at a different position in the ring. So the first compound will give us two final products with the molecular formula C7H10. So number 1 cannot be the answer. Okay, let me cross this because it gives us two final products. So let me erase all these. We're going to redo the whole thing. We start with compound number 2 now. Now because compound number 1, 2, 3, they are very similar. Okay, so probably this time I do not need to show all the hydrogen again. Right, you probably want to try to restart, okay, with compound 1, 2, 3 later by yourself. Alright, now let's look at compound number 2. Compound number 2 now. So same thing, we have, okay, we have the ring. This time, okay, we have this ketone, okay, and this aldehyde. Now first step, reduction. Okay, reduction means I have to change this to, I am converting this to a secondary alcohol. And the aldehyde to a primary alcohol. Alright, now remember this primary alcohol, there's only one neighbor carbon with hydrogen. So the reduction, okay, will give me an alkene here. Now this OH, I can remove hydrogen from this left hand side carbon or the right hand side carbon. Now let's remove the hydrogen from the left hand side carbon. I'll get a compound like this. Okay, this is my first C7H10 product. Now let's do another one. We remove hydrogen from the right hand side carbon here. Okay, so what do I get is, this one is still the same, but this now double bond is here. Now can you see that these two are actually same type of molecule? They are the same. Why? Because this one, if I just rotate this thing, okay, along this axis, okay, along this axis, it will become this compound. So they are actually identical. So number 2, okay, compound number 2 actually give us only one final product because they are the same thing. So yes, okay, number 2 is one of the answers. Now let's check if number 3 is also the answer. So I'm going to start with number 3 now. Okay. I'll draw it on the right hand side this time. So this ketone will be reduced to a secondary alcohol. This aldehyde, a primary alcohol. So again, yeah, we will do the dehydration now. Okay, dehydration. The first product I'm going to remove, okay, I'm going to remove the hydrogen from this carbon. I get this. Okay, this one always remove the hydrogen from the only adjacent carbon. So I will get this compound. Okay, now let's look at the second dehydration. You see, I can first, okay, dehydrate this alcohol to get this alkene here. Now, once this one is formed, right, this alkene is formed, we cannot remove hydrogen from this carbon anymore to dehydrate this alcohol. So this alcohol actually can only take the hydrogen from this carbon. So at the end, we will still get this because it has no other options. Cannot take hydrogen from any other carbon because this hydrogen is removed together with this OH to form, okay, the double bond here already. Therefore, again, number 3, there is only one product. So number 3 is also the answer. So answer is 2 and 3 only are correct. C.